Yes, welcome back to the next session. That is, in the last session we have identified how to we got to know how to identify the given function is a 1 1 or not. Now next concept we will go, that is identifying the given function is onto or not. Whether the given function is onto or not. Very simple it is. A given function, f maps from A to B is said to be onto if every element y belongs to B, there exists if for every element y belongs to B, there exists an element x in domain, that is A, is called an onto function. Simply if I write the definition like this, you may not understand. Let me go with an example. Let me take an example of a function f. It maps from n to n, means natural numbers to natural numbers. Natural number is the domain and a natural number is the codomain here. A function f maps from n to n, defined as f of x is equal to x. I want to identify this given function is onto or not. So what you do to identify this is first family and this is second family, mapping from n to n natural numbers. This one is also natural numbers. We are mapping under the function f of x is equal to x. What you do? You write all these entries first, and here also what are the elements? Here also entries are 1, 2, 3, 4, 5, 6, so on. It is like this. F of x is equal to x is there. When you take x is equal to 1, what is f of 1 is equal to? That is nothing but 1. Means 1 is related to 1 here. Next step, if you substitute 2, it gives us a 2. 2 is related to 2. 3 is related to 3. 4 is related to 4. 5 is related to 5. You see, any element belongs to the codomain have free images in the domain or not? ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಗಳಿಗೆ ಫ್ರೀ ಇಮೇಜಸ್ಗಳು ಅದಾವೋ ಇಲ್ಲ ಅಂತ ನೋಡ್ರಿ. Yes, all the elements in the codomain have free images in the domain. In that case, we say the given function onto. Elements should not be left behind in the codomain. That is how we should identify the given function is onto or not. Or I will tell you another way. One thing is that domain and codomain will be directly given to you, like a function maps from n to n, in the sense domain is first one and codomain is second one. Now what you do, you should find range of the given function. If range is equal to codomain, then the given function is onto that sum. Very simple. Third way of identifying the given function is onto or not, codomain of the function should be equal to range of the function. If this thing satisfies, then the given function will be onto. Very easy. So in case of identifying the given function is invertible or not, we should have the definition, and for that we should know the given function is 1 1 or not. To identify the given function is 1 1 or not, I will take graphical method. That is first one, identifying the given function is 1 1 or not. And to identify, I will follow this method, that is codomain is equal to range or not. Now coming to the definition of inverse. What is the definition of inverse? Definition of inverse I will use in writing all 6 trigonometric functions inverses. Okay, first one, definition. A function f maps from A to B is said to be invertible, then there exists an another one function. There exists a function G which maps from B to A. This is important. If A is invertible, means if A is bisective function, 1 over and on 2, then its inverse exists. We say its inverse exists. If inverse exists, then there is another one function that will be represented as a G. That G maps from B to A, where A is mapping from A to B, then G will map from B to A such that F circle Z of X is equal to, otherwise let me write simply, F circle Z is equal to is an identity function in the domain B. And next, and also Z circle F is also an identity function in the domain A. Okay, F circle Z and Z circle F, these two will be identity functions where G is called inverse of F. Yes, G is called inverse of F. Fine. This will be represented as F inverse. J is equal to F inverse. We may not understand with this definition directly. So what I will do, I will take an example here. Let me take the example. There is a function F. Which maps from R to R, defined as f of x is equal to 4x plus 3. F of x is equal to 4x plus 3. You identify this 1 overness and ontoness of the function. This given function is 1 over and onto, so the given function is a bijective. According to this definition, I will write here. See, f of x is equal to 4x plus 3 is the given function. Then I will identify another one function g, which is inverse of this given function f. How will you identify? You just to take f of x is equal to y. What is f of x is equal to? That is 4x plus 3, which is equal to y. Separate for x. 4x is equal to y minus 3. X is equal to y minus 3 divided by 4. See, f of x is equal to 4x plus 3 we have written, and then this x is equal to, you write z of y is equal to, g of y is equal to y minus 3 divided by 4. According to the definition I am going, f is a given function. If it is invertible, then there exists another one function g, which maps from here R to R is there, again it maps from R to R, then this function is inverse of this. If it is inverse, it will follow this. What is that? F circle Z is an identity function and Z circle F is also an identity function. Let me check this. First of all, I am going with the F circle G of Y. Z of Y in the sense Y is an element in the domain of Z. Domain of Z is what? Domain of Z is B. This is an element in B. Fine. F circle G of Y is nothing but F of G of Y. F of G of Y. F of, what is G of Y? Here substitute that. G of Y is nothing but Y minus 3 divided by 4. F of Y minus 3. See, F of X is equal to 4x plus 3. In place of X, what we have here? In place of X, we have Y minus 3 divided by 4. Now, going according to the given function f of x is equal to 4x plus 3. In place of x, you substitute y minus 3 by 4. Now, 4 will be as it is. In place of x, I will write y minus 3 divided by 4. This plus 3 will be as it is. Plus 4 minus 4 get cancelled. Y minus 3 plus 3 get cancelled. We are getting y only. What was the element? Y was there. Again we are getting y only. In the sense here, f circle G is an identity function. Fine. Now checking the second one. Z circle f of x is equal to, what is x here? X is an element in the domain of the function f. Now if you substitute that, again we will get the same thing or not. Let me check it. Z circle f of x is equal to is nothing but g of f of x. G of, I will substitute this inner function f of x. What is f of x? F of x is 4x plus 3. Let me substitute this. 4x plus 3 is equal to z of y equal to y minus 3 by 4. In place of y I have 4x plus 3. Let me substitute in that. Y is nothing but 4x plus 3. This minus 3 will be as it is, whole divided by 4 will be as it is. Plus 3 minus 3 get cancelled. 4x by 4, 4 get cancelled, which is equal to x. See, we have the function g circle f is an identity function. Means a given function f, if it is invertible, then f circle g and g circle f will be identity functions. These are all the concepts required to study inverse of trigonometric functions. Now, inverse of trigonometric functions. There are 6 trigonometric functions are there. We will study inverse of all those 6 trigonometric functions, their domain, range, and all those properties we will study in the second PUC chapter, that is inverse trigonometric functions. Okay. Now, I will take the first one, that is inverse of sine function. Inverse of sine function. Inverse of sine function we are going to study now. See, sine, if you take, it maps from r to r. Sine in the sense it is like function f. It is mapping from r to r. Will it be 1 1 and r to? No, it will not be 1 1 and r to. How? Let me take the example. What is sine 0 degree? Sine 0 degree is 0. And what about the sine 180 degree? Sine 180 degree also 0. Element 1 and element 0 and 180 have the same image. The given function is not 1 1. And what about onto? Is it onto? No, it is not onto, because in the codomain elements other than the interval -1 to +1, values above the 1, values below the -1, those are not the images. Sine will not give us all those values. That means the given function is not onto also. To make the given function onto, what I will do, we will restrict its domain and codomain. We will to make the given function 1 1 and onto, we will restrict the domain and codomain. Or to make the given function onto, what you do, you restrict its codomain to -1 to +1. Means codomain I am considering only in the interval -1 to +1. What is the range of the trigonometric function sin theta? That is from -1 to +1 only. Here I am considering the codomain close interval from -1 to +1. Range is equal to codomain now. When we have range is equal to codomain, the function becomes onto. Okay. Now, first thing we solved, the given function sine is becoming onto. Now, next thing is to make the given function 1 1 by restricting the domain. How will you restrict? For that, we need to go with graphs. Okay. Let me explain the graph of sine theta. This is y is equal to sine x. On x-axis, we will consider domain values, means 0, pi by 2, pi, 3 pi by 2, and 2 pi. Left hand side, minus pi by 2, minus pi, minus 3 pi by 2, like that it goes. And then on y-axis, we will consider range values. Here is +1, then -1. Now, what is sine 0 value? Sine 0 value is 0, point is 0, 0. Sine 90 value is 1. Means x is equal to 90, y is equal to, we will get 1. So, point is 90, 1. 90, 1 means point is here. Graph takes the form like this. Sine of 180 degree is 0. Graph goes like this. and sine 270 degree is a minus 1, sine 360 degree is a 0 again. In the left hand side also it follows the same thing. This is what the graph of sine theta. I told you the graphical method of identifying the given function is 1 1 or not. How? Draw the graph of the function, then draw horizontal line anywhere. If it touches at only one point, then the given function is a 1 1, otherwise no. You draw the horizontal line anywhere here. How many times it is touching? It is intersecting at many points. So for that, what you do? If you consider domain as all the real numbers, this given function will not be 1 1. So what we do? We restrict its domain. How will you restrict? Let me restrict it from minus pi by 2 to plus pi by 2. I am restricting from minus pi by 2 to plus pi by 2. You consider graph only in this interval minus pi by 2 to plus pi by 2, means minus 90 to plus 90. You draw the horizontal line anywhere here. How many times it is intersecting? It is intersecting at only one point. You draw anywhere. See, it is intersecting at only one point. Here you draw. It is intersecting at only one point. That's why what I am doing, I am restricting the domain. Means sine, I am considering the domain from minus pi by 2 to plus pi by 2. Range will be minus 1 to plus 1. I told you while telling the definition of the inverse, if f is a function which maps from a to b is 1 1 and on to, then g will be its inverse which maps from b to a. Means sine is a function, it is 1 1 and on to in this domain and codomain, its inverse exists, because in this domain and codomain the given function is 1 1 and on to. We will write its inverse as a sine inverse. Sine inverse, it will map from minus 1 to 1 to minus pi by 2 to plus pi by 2. Now, what is the domain of sine function? Domain of sine here, I am restricting from minus pi by 2 to plus pi by 2 and its range is minus 1 to plus 1. Now coming to the sine inverse. What is the domain of sine inverse? Domain of sine inverse is minus 1 to plus 1. What is the range of sine inverse? Range of sine inverse is from minus pi by 2 to plus pi by 2. You should remember this. Okay, now one more thing is that, this is the fixed range or not? This is the fixed range? No, it will not be the fixed range. You can take any range such that the given function becomes 1 1. How? Instead of choosing from minus pi by 2 to plus pi by 2, you can choose from minus 3 pi by 2 to plus minus pi by 2. You see, minus pi by 2 to minus pi by 2 also, minus 3 pi by 2 to minus pi by 2 also, the given function becomes 1 1. And pi by 2 to 3 pi by 2 also you observe. 3 pi by 2 to 5 pi by 2 also you observe. All those intervals we can consider. In those intervals also the given function will be 1 1. Those can be considered. Means range of sine inverse of x can be minus 3 pi by 2 to minus pi by 2, or minus pi by 2 to plus pi by 2, pi by 2 to 3 pi by 2. Similarly, 3 pi by 2 to 5 pi by 2, 5 pi by 2 to 7 pi by 2, anything we can consider. All those are correct. But why you have chosen this one? This branch is there, minus pi by 2 to plus pi by 2. This branch is called as a principal value branch. They may ask you to write what is the principal value branch of sine inverse. Principal value branch is nothing but range. Range of sine theta, range of sine inverse of x is same as principal value branch. Let me write it here. Principal value branch. Principal value branch of sine inverse of x is nothing but minus pi by 2 to plus pi by 2. These are all the other branches. They may ask you the questions like write the range of the sine inverse other than the principal value branch. In that case, what you will do? You write any of this interval. Otherwise, you draw the graph and identify clearly. You write any interval, that will be correct. Okay, thank you. In the next session, we will draw graph of sine inverse and we will deal with other 5 trigonometric functions inverses.